Redivis is a platform where organizations upload rich datasets that researchers can discover, access, manipulate, and analyze. Today we're going to walk through a typical researcher's workflow on Redivis. Our topic for this walkthrough is to investigate the relationship between opioid prescriptions and unemployment in the United States. We'll want to first find the raw data we need and then manipulate it into a cleaned, manageable subset that we can visualize and analyze further. Let's begin by looking for data in an organization. Organizations create branded data portals on Redivis in order to distribute datasets related to their research mission. For this video, we'll use the Redivis demo organization, which you can explore yourself at redivis.com/demo. Let's search in this organization for datasets related to opioid prescription. The Redivis search engine performs a deep search that not only looks at a dataset's name and documentation, but also at variable metadata and value labels. Our top search result is the CMS synthetic patient dataset, which consists of multiple tables, some of which have hundreds of millions of records. Notably, the drug exposure table, with 126 million records, matched on 9 variables in the search query. Let's explore these variables to see if this table has information about opioids. Here we see a variable for the quantity of drug prescribed and can view its univariate statistics that were automatically computed on the source data. We want to look at opioid prescription drugs, so let's search opioid. Here we see that the drug concept ID variable contains information about the type of drug prescribed. If we search the frequency table for opioid, we see the codes and names for the most common opioids in the value labels. This dataset seems like it might have what we need. Let's learn a bit more about it. On the dataset page, we can view the documentation, metadata tags, and information about its ontological structure. This dataset is made up of 24 tables. Let's confirm that we have geographic information about the prescriptions, since we'll ultimately want to link them with county-level unemployment data. If we search on county, we see that this information is in the location table. At this point, we've validated that this dataset has what we need, and to work with it further, we'll want to add it to a project. However, this option is currently disabled because we only have metadata access to the dataset. Organization administrators can define detailed and varied access rules for their datasets. They can make a dataset completely public or private, or create requirements for different levels of access. For this dataset, its documentation and metadata were publicly available, but we must take additional steps before querying the data. Let's see what's necessary for further access. This dataset just has one requirement. It looks like the organization is collecting some basic information about its researchers. Requirements are highly customizable and can be defined by organization administrators however they see fit. In this case, I'm auto-approved when I submit the form, though for other requirements, an administrator might choose to review my submission before granting approval. Now that we have data access, let's add this dataset to a project. Projects allow us to combine and manipulate data from across Redivis, bringing scalable, high-performance tools to a well-organized and reproducible workflow. For our project today, we want to develop a data cut that measures the annual opioid prescription rate by county and tie this information to the county's unemployment rate. Here we see the latest version of the CMS dataset that we added. Redivis defaults to the 1% sample of large datasets to speed up exploration. However, to highlight performance, we'll work with the full dataset today. The prescription table that we saw before contains over 100 million observations, everything from antibiotics to heart medication. For our research question, we only want to look at opioids. Let's start by looking at a common opioid, fentanyl, which we see is coded as 1154186. To extract a subset of the table's records, we'll create a transform. Transforms provide a powerful interface for us to filter, manipulate, and merge tables within our project. Let's start by narrowing this massive table down to records with a fentanyl prescription. We'll also choose which variables to propagate to this transform's output. Let's keep information about the drug, quantity, date, and location. When we run this transform, it filters the 126 million records in the drug exposure table and creates a new output table. Here we see it has just over 300,000 records where fentanyl was prescribed. This transform wasn't cached or sped up in any way. Redivis autoscales to meet the needs of our query, easily handling tables with billions of records in real time. We want to count prescriptions of all opioids, not just fentanyl, so let's include the additional codes in our transform. We also want to aggregate the number of opioids prescribed per year, so let's create a new variable that extracts the year from the prescription date and run our updated transform. Under the hood, a transform is a graphical interface that generates standard SQL. We can view and export this SQL and even write our own queries if we prefer a programmatic interface. In the updated output table, we now have all opioid drug events and their year of prescription. Our next step is to link information about the county where each opioid was prescribed. To do this, we'll join records from our opioid prescriptions table with the location table using the location ID as a join variable. We'll want to keep the year and quantity of each opioid prescription alongside the linked county variable. Now we can run this transform. The output table shows a list of all individual opioid prescriptions by year and county. However, we want to compute the total opioid prescriptions in each county in a given year. To do this, we'll create an aggregate variable that computes the sum of opioids partitioned on both county and year. Let's keep the year, county, and total opioid variables and run this transform. This generates an output table that, for every county and year, gives us a total amount of opioids prescribed. With Redivis, we can easily combine a wide array of datasets hosted by different research organizations. Now that we have information about total opioids by county, we can bring in unemployment data as another dimension. In our project, we'll add the BLS unemployment dataset. We can see that it has the relevant variables for annual unemployment rate by county. Let's join this table with our opioids table on county and year and propagate the variables that we want to use in our final analysis. We're ready to run our transform, but it's invalid. As we all know, data are not always as clean as we'd like. The county variable in one of our tables is an integer, whereas in the other it's a string, probably due to some leading zeros in the data upload process. Luckily, with Redivis, we can dynamically retype variables. If we first cast this county variable as an integer, our transform is ready to run. We now have an output table with just over 9,000 records, far more manageable than our original 126 million records. Our final output table contains annualized county-level data about the unemployment rate, population, and total opioids prescribed. With this simpler and well-structured table, we can now begin to further analyze and visualize our data. Redivis provides broad flexibility here, complementing the tools that we know and love. We can export our table in multiple formats to work with it locally or reference it directly from the software of our choice. It's these visualizations that drive home the findings in our research. Here we're looking at chloropleth maps that display the opioid and unemployment rate by county and year. We see unemployment skyrocket across the country due to the 2009 recession, alongside interesting regional relationships between unemployment and opioid prescriptions. We can also create quick interactive visualizations with the Redivis Data Studio integration. Here we see a scatter plot comparing the percent increase in unemployment to the percent increase in opioid prescription rates. Finally, we can use the Redivis R and Python client libraries to interact with our table in a notebooks environment, connecting our data with countless open source toolkits. This concludes our walkthrough, but it's really just the beginning. We encourage you to further explore the Redivis demo organization and its datasets. Comprehensive documentation is also available at docs.redivis.com, where you can find more guides and learn about the many features we didn't have time to cover here. We'd also love to talk to you about your research and data management needs. Please go to redivis.com to request a demo or to contact us for more information.